All right, today we're going to unpack a paper that really truly changed how we think about teaching AI. It's called Deep Reinforcement Learning from Human Preferences, and it showed us a whole new way to get machines to understand our goals, not with lines and lines of complicated code, but with simple, intuitive human judgment.
So, to really get why this is such a big deal, think about this for a second. How would you actually program a robot to make the perfect scrambled eggs? Seriously, would you reward it for how fast it whisks, for keeping the heat just right, for fluffiness? How do you even code fluffiness, right? You see how this gets super complicated super fast.
And that right there, that's the core problem this paper tackles. I like to call it the AI wish problem. It's this huge gap between the instructions we think we're giving an AI and the outcome we actually want. It's like having a mischievous genie who takes everything you say literally, often with, well, let's just say unexpected results. You see, in the world of AI, those instructions, we code them into something called a reward function. The easiest way to think about it is like the scoring system in a video game. The AI's entire purpose in life is just to get the highest score possible by following the rules that we wrote down for it.
But what happens when our rules aren't quite right? For example, if you tell an AI to maximize grip strength, it might just crush the very thing it's supposed to be holding. It's following the rule perfectly, but it's completely missed the point, the intent. This is what we call reward hacking, and it is a huge, huge problem in AI safety.
So if trying to write the perfect rulebook is just too hard, what's the alternative? Well, the researchers came up with this honestly beautifully simple idea. Instead of us writing the rulebook, what if we let the AI learn the rules just by watching us judge what it's doing?
So the big idea here is to put a human, a real person, right in the middle of the training loop. Instead of the AI learning from some pre-written score, it learns from our judgment. Our simple choices are used to build up a model of what the reward should be, and that model then guides the AI. Now, we'll get to what these results mean in a second, but first, let's break down exactly how this whole learning process works.
It all boils down to this really simple but powerful loop. First, the AI tries out a couple of different short actions. Second, a human watches 2 little video clips of those actions and just picks which one they like more. And finally, that one single choice helps the AI update its own internal idea of what it's supposed to be doing. And this just repeats over and over again, with the AI getting a better and better picture of our goal. And for the human, the job is incredibly simple. Seriously, you're not coding, you're not writing out complicated scores. You just watch a couple of super short clips, like 1 or 2 seconds long, and you click on the one that looks better. That's it. It's fast, it's intuitive, and you don't need to be an AI expert to do it. Okay, so the idea sounds great, right? But does it actually work? To find out, the researchers put this thing through its paces in 2 classic AI training grounds: complicated robot simulations and good old-fashioned Atari games. First up, the robots. In these really complex tasks like walking and hopping and even swimming, the AI that was learning just from people's preferences, well, it learned the skills, and its performance was almost as good as an AI that was basically given the cheat codes, the perfect handwritten reward function from the very beginning. I mean, that's a huge win. And it wasn't just for robots. The same method worked for playing old-school Atari games, which is a totally different kind of challenge that's all about understanding pixels on a screen. On games like Beam Rider and Pong, it learned to play pretty well. And on Enduro, get this, it actually did better than the standard AI. Why? Because the human feedback was kind of getting it smarter hints about what really matters, like passing other cars. Okay, so it can learn tasks where we already know the answer. But what about the really cool stuff? The stuff that we don't even know how to program? Could it learn something completely new just from our gut feeling? And this is where things get really mind-blowing. The researchers taught this little simulated robot to do a backflip. Just think about that for a second. How would you write code that says, do a good backflip? It's basically impossible. But with just about an hour of a person sitting there clicking, that one looked a little better, the AI figured it out all on its own. So this wasn't just some cool party trick. This 2017 paper was a massive step towards building AI that's aligned with what we humans actually want. And in fact, the technique it pioneered, it's pretty much the direct ancestor of what's used to align the huge language models we all use today, like ChatGPT. Its fingerprints are all over modern AI. And here's the really crucial part, the reason this was such a game changer. It was efficient. The system didn't need someone watching its every move. Actually, the human only had to give feedback on less than 1% of what the AI was doing.
And that efficiency is what made it a breakthrough. For the very first time, it proved that learning directly from people wasn't this impossible bottleneck. It was a real, practical, and scalable way to train some of the most complex AI systems out there. The authors themselves put it perfectly in their conclusion. The whole point of this is to get AI to serve our complex human values. Things like do a cool backflip or clean the room without breaking anything. Not just these simple, low complexity goals we can easily write down in code. So yeah, this research really opened a door to a massive question that we are still trying to figure out today. If we can teach an AI what we prefer just by looking at a couple of video clips, where does that road end? Can we eventually teach it to understand and maybe even act on our deepest, most complex human values?
This is for entertainment purposes only.